the primary tissues and their subtypes. So first of all, we know the cell is a basic structural and functional unit of the body. It's arguably the most important subunit of the body. You can't accomplish anything without the cells and the processes that happens inside the cells. The replication of DNA, all types of good stuff, synthesis of proteins, synthesis of enzymes, all of these happen within a cell. Now, cells are going to group themselves according to likeness. So like cells will come together and form like tissues. All right? Let's take a liver cell. They're all going to group themselves within the liver and form a like tissue. Let's take an endothelial cell, the cells that line blood vessels. They're all similar in nature. They want to achieve a similar function. They line themselves up to form a like tissue. And tissues do that same thing. So tissues are going to orchestrate themselves within an organ to bring about different functions. So let's take the heart. All of the muscle cells in the heart are going to orchestrate themselves to form the ventricles. All of the endothelial cells of the heart are going to line those ventricles, line the blood vessels. All of the connective tissue cells are going to create connective tissue, which lines the heart. So within a specific organ, you have differing tissue groups lining themselves up to bring about a function. Okay? And then different organs are going to work together to bring about a system or body system. So the heart, the lungs, the brain, they're all different organs and they're working together. None more important than the other. Right? The brain is the communication, the networking. It allows anyone to communicate, talk to each other through neurons. The heart is pumping oxygen. But who brings in oxygen? Who brings in oxygen? The lungs. So the heart is circulating the oxygen that the lungs brought in out to the different tissues. What does the GI do? Digest food. And what's the most important thing that every other cell needs that's brought in by the GI? What's that molecule that the brain cannot function without? Glucose. So we need a GI. Every organ is playing a part in creating this body system. Okay? And these body systems create an organ. So let's look at the primary tissue types. We have four main tissue types. And again, these are going to be grouped by like cells creating a special function. We have muscle tissue. Muscle tissue is specific in that it's the only contractile tissue. And it's one of the most unique, one of the most amazing, again, in my perspective, tissues of the body, because it has a mechanism to actually shorten, which allows us to move, walk, talk, breathe. Okay? Nervous tissue is also quite important. Muscle cannot move without nerves. So you need that network of how the brain talks to the rest of the organs and creates and gives that information, those impulses. Connective tissue sort of does everything else. It fills in the spaces, so loose connective tissue, that's your fat, fills in the spaces, it's going to give cushion to the body, protect vital organs. It's also going to bring blood supply to the epithelial layer, which is the fourth tissue type. So the epithelial tissue lines body cavities. It's going to form your skin, which forms a protective barrier. It's going to be the lining and the barrier formation. That's the tissue we're mainly going to focus on today. Epithelial tissue. Okay. Now, epithelial tissue is also called endothelial, so the cell that lines the blood vessels. So when it's around a blood vessel, it's called endothelial. When it's everywhere else in the body, lining the heart, lining the lungs, it's called epithelial. The skin is epithelial. And again, each tissue has a special function that's going to dictate the way it looks, the way those cells behave, and so on and so on. So that theme that we see in anatomy and physiology where form follows function. So the way a thing looks is going to help you understand how it functions. Any questions so far? All right, the second objective here is to list the functional and structural characteristics of epithelial tissues. Now, when you look at epithelia, the main thing is classifying epithelial tissue. So we classify epithelial tissue based on two things: the number of cells that are found in that tissue, the number of cells, as well as the shape of those cells. The number of cells and the shape of those cells. So if a tissue has one layer of cells, it's called simple, it's a simple epithelium. If it's a layer of cells that's stacked upon each other, so several layers of cells, it's called stratified epithelium. So simple epithelium, one layer of cells, like we see in our blood vessels. We're going to see the function of those types of tissues in a minute. Stratified epithelium is when we stack those cells on top of one another. So several layers of cells. And this is the unique function of that as well. Now again, we can classify them based on their shapes. So flat cells are called squamous cells. Cube-shaped cells, so cells that are as tall as they are wide, are called cuboidal. And columnar cells are tall cells. So they're taller than they are wide. So in order to name a tissue, we're going to put the number of cells, right, whether it's one layer or more than one layer, along with the shape of the layer at the top. Right? So the topmost layer is going to be the name of that tissue. All right. So we said this is a squamous cell, right? It's flat. This is a cuboidal cell. It's as tall as it is wide. So it's shaped like a cube, cuboidal. And this is a columnar cell. Right? And this is the shape of the cell. So you're going to classify each cell on its shape. Now, when we look at a tissue, we can have a single layer of squamous cells. A single layer of squamous cells. And we said if it's a single layer of cells, it's called simple. So this tissue type would be simple squamous. Right? One layer of cells that are flat shaped. Similarly, we can have simple cuboidal. Again, one layer of cells that are cube shaped. And we can have simple columnar. Now, columnar cells usually have an apical modification, and we're going to talk about that more later on, but I'll just draw it out here. So these are your columnar, again, simple columnar epithelium. Now, we also said that they can be stratified. So if you had a group of flat cells that was stacked one on the other, This would be called stratified. Again, because we have more than one cell layer, squamous. Stratified squamous epithelium. And again, similar for your cuboidal. If we had a group of cuboidals stacked on one another, this would be stratified cuboidal. Okay, so we can see that a tissue type is going to be dependent on two things. The shape of the cells, again, at the top, so the top layer of cells, because we can see that stratified squamous can also have some cube-shaped cells at the bottom. So we're specifically looking at the shape of the top layer of cells, as well as how many layers. So if it's one cell layer, it's simple. More than one, it's stratified. Okay? You know, like I mentioned before, the columnar cells have some modifications. So they have goblet cells, and goblet cells secrete mucus. And we're going to see, based upon the location of columnar cells, mucus production is going to be very important. So we're going to find goblet cells along with cilia. So cilia are those little hairs that I do. And they're going to help move that mucus as well as any debris. They're going to be found in the respiratory tract. So again, the location of columnar cells is going to be very important to have cilia, which helps to move the contents of that lumen along with mucus production. Just to remind you here, epithelial cells are going to line the body cavity, so the inside of your gastrointestinal tract, the inside of your respiratory tract, the inside of your blood vessels. Any hollow organ, the skin is lined by epithelial tissue. Inside your mouth, your mucous membrane, that's all epithelial lining. All right, so some characteristics of epithelial tissues. First of all, they have cellularity, which means that they're their own structure and separated by minimal extracellular material. Cellularity just means that they have the same properties as any other cell. They're composed within a membrane, and they're separated by minimal extracellular material. They have specialized contacts. So they're not just going to be sitting one next to the other. They're actually junctioned or anchored next to each other and onto a basement membrane by several junctions. So you can see this one again. We're going to talk about each of these in a minute. But they're not just floating independently, they're anchored or junctioned together. Next, they have polarity. And what polarity means is that there's a top layer or an apical region, there's a basal region or bottom layer, bottom surface, also called a basal domain, and then there are two lateral domains. So there's an apical surface, a basal surface, and lateral surfaces. That's what we mean by polarity. This surface is going to be facing the inside of the lumen of that structure. So this is a gastrointestinal epithelial cell. This is where your food is passing. It's lining the surface of your GI. And food is flowing through your GI. Next, they're supported by connective tissue. Okay, so this is your epithelial layer. Again, these are your cells. In this case, they're columnar cells. But they're sitting on a basement membrane. Okay. And the basement membrane is made up of the basal lamina, which is that area or that surface of connective tissue that the cells sit upon or rest upon, as well as reticular fibers. So you can see some straw-like fibers here. These are called reticular fibers. Reticular fibers. They're going to help to give structure and support to that basement membrane. Now, two important things. Epithelial cells are avascular, meaning that they do not have a blood supply. So there's no blood vessel going here and feeding these cells. They have to get their nutrients from the basement membrane. But they are innervated. So you can see this nerve. It's called the cutaneous nerve. So they innervate the skin, or if it's in the GI tract, it'll be a GI nerve. It's going to go and feed this cell. So they're avascular, no blood supply, but they are innervated. So they do get nerve innervation or nerve supply. That's why you can feel your skin here, cutaneous innervation here. But if you scrape off the very top layer of your cell, it won't bleed for a while. You're going to have to go down into the dermis to get blood vessels. That's going to be important when we talk about the regeneration of epithelial cells. They're going to have to come up from the bottom. So the cells that are closest to the basal membrane, they're getting blood supply. So they're the newer cells, they're the fresh cells. They're being regenerated. And when they get to the top layer, in the case of stratified tissue, they're going to slough off. So because they can't regenerate, there's no active blood supply, they're going to die off and slough off. That's what happens to your skin every couple of days. The layer closest to the bottom, closest to the dermis, rises to the top. When it gets to the top, it dies and just sloughs off. Okay? Because again, it does not have blood supply as it gets to the top. So these are some properties of epithelial cells. I'll just point out a few things here again. We have an apical surface, a basal surface, a lateral surfaces. This is the connective tissue that's underneath the epithelial layers. This is the epithelial layer. This is the underlying connective tissue. Use that connective tissue was like an insulator. There's lots of fat there. As well as the basement membrane formed by the basal lamina and the epithelial.